Hello guys, welcome to my channel. Today we have to discuss about the Bayes strain theory. This is the most important question in BSc chemistry first semester. This question will be asked as first semester definitely question. Then Bayes strain theory. What is Bayes strain theory? We have to discuss about it. In cycloalkanes, all the carbons are having sp3 hybridization, so its bond angle is 109 degrees 0.28, but it's deviated in cycloalkanes. In alkenes, all the carbons are having sp3 hybridization. In cycloalkanes are sp3 hybridization, so its bond angle is 109.28 degrees, but it's deviated in cycloalkanes. So it is affected with the same amount of strain. Then it is called as bond strain theory of cycloalkanes. Then some of the cycloalkenes affected with the outward strain or after affected with the inward strain. These cycloalkenes are affected with the outward strain or inward strain. Then to calculate bond strain of cycloalkenes, Baeyers drive an equation. These are the equation to find the bond strain in cycloalkenes or another complex structures. Then the formula is bond strain is equal to 109.28 degrees minus present bond angle. The present bond angle at which the cycloalkanes which had bond angle, then the present bond angle is defined as here, then by 2. For example, we can see examples to explain, and you can understand easily by explaining of examples. Then for example, we have to take cyclopropane. The structure of cyclopropane is, this is called a cyclopropane. There are propane means 3 carbons. There are 3 carbons. It is in cyclo form. Then what is present bond angle? What is its present bond angle? Then the present bond angle is 60 degrees. It is 60 degrees. So 109.28 degrees minus 60 by 2 is equal to 24.64. Its bond strain is equal to 24.64 degrees. Then we have to see next example. In cyclobutane, the bond strain is, then the structure of cyclobutane is butane means 4 carbons. There are 4 carbons. It is in cycloform. Then it is called as cyclobutane. Then the bond strain is equal to 109 degrees, 109 minus 28 degrees minus the bond angle is 90 degrees. The present bond angle is 90 degrees. So minus 90 by 2 is equal to the bond strain is 9.64 degrees. Then we have to take next example, cyclopentane. Pentane means 5 carbons. The structure is 1, 2, 3, 4, 5. Then what is the present bond angle? 108 degrees. The present bond angle is 108 degrees. Then 109 minus 109.28 degrees minus 108 by 2 is equal to 0.4. The bond strain of cyclopentane is equal to 0.64 degrees. Then next example is cyclohexane. What is the structure of cyclohexane? Hexane means 6 carbons. Then 1, 2, 3, 4, 5, 6. It is cyclohexane. Then the bond angle of cyclohexane is 120 degrees. So minus 120 degrees by 2 is equal to minus 10.72 by 2 is equal to minus 5.36 degrees. These are the bond strain of cyclohexane. Then To the above calculation indicates cyclopropane and cyclobutane is affected with inwards bond strain. Cyclohexane is affected with outward bond strain. The cyclopropane and cyclobutane, these cyclobutane and cyclopropane are affected with the inwards bond strain. These are the inwards bond strain. Inwards bond strain. Then the cyclohexane is affected with the outward bond strain. Cyclohexane is outward bond strain. Then the cyclopentane does not affected with any bond strain, so it is called as Baeyers cycle. The cyclopentane. What is cyclopentane? Here, the cyclobutane and cyclopropane are inwards bond strain. The cyclohexane is outward bond strain, but the cyclopentane does not affected with any bond strain. So it is called as Baeyers cycle. This is an important point to remember. To avoid the outward bond strain, cyclohexane forms mainly two ring structure or conformers. To avoid outward bond strain, to avoid cyclohexane, the cyclohexane forms mainly two ring structures or conformers. These are the two ring structures I will explain. The cyclohexane will be mainly forms two ring structures. They are a chain form and a bond form. The cyclohexane will be forms this is chain conformers of cyclohexane or chain ring structure. Then it contains chains, so it is chain conformers. But in this form there are no chains, it is formed with bonds, so it is called as bond conformer of cyclohexane. These are the two ring structure or conformers, you have to remember it. Then this bond and this bond is referred as HEA and HE. This HEA is equal to axial hydrogen. Then the HE is refers as equatorial hydrogen. Then the chain conformers is more stable than bond conformers. These chain conformers, for going stability order, the chain conformers are more stable than bond conformers because less stirring interactions. It has less stirring interactions are present in between atoms of chain conformers. In between of chain conformers, the stirring interactions are less, so then the chain conformers are more stable than the bond conformers. This is a total topic about the Baeyers strain theory. It is an important question. It will be asked in first semester chemistry. You have to remember and study it. Thank you.